So now let's talk a little bit about arithmetic. Arithmetic is just like it would be in any other class. Well, not any other class, but like math classes. And we have some pretty standard operators with arithmetic. We have our plus, which is going to be addition. We have our minus, which is going to be subtraction. This is going to be multiplication. This is division. And this is a new operator for most of you called modulus. And we'll talk a little bit more about division and modulus at the end of this video. So with addition, it's just like its standard would be in math. 1 plus 1 is 2. You get things like 2 plus 10 is 12, or something like 123 plus 17 is 140. So it's pretty standard. You could really, if you wanted to, you can go into the infinity and like 1 plus 2 plus 3 and just keep going. So that would be like 6. But as complex as you could get in math, you can get with a computer. You have subtraction, which is going to be just like math, again, where something like 1 minus 1 would be 0. 10 minus 17 goes to negatives. 100 minus 62 is 38. And same thing with addition. You can just keep putting like a number minus a number minus a number. But you can also like add a number into there, which would be, that's negative 26 plus 1. So that would be negative 25. You get things like multiplication, which is going to be pretty standard, where you get things like 2 times 1 is 2, 2 times 10 is 20, 15 times 10 is 150. And just as before, you could add in like a times 0 here, and it would be the same because precedence, but, well, precedence and its first, but we'll talk about precedence in a little bit. But then division's where things start to get really interesting. So like 9 divided by 4, that's 2.25. But in a computer, 9 divided by 4, that's only going to be 2. Well, if they're integers, which in this case they are. But how do we get that remainder of 1? We get that through the modulus operator. So 9 divided by 4 gives us 2, which, yes, 9 divided by 4. 4 times 2 is 8. We can't put 4 into 1 nicely, so we just cut it off and we're done. And we get that with the modulus. So we get some examples of division, like 8 divided by 2 is going to be 14. 10 divided by 3 is 3. 9 divided by 2 is 4. And those are kind of weird because, 3 times 3 is 9. Well, that's not so weird because that's going to be 8. And then this one is 4 times 2 is going to be 8. That's really weird because, like, 9, you're telling me 10 divided by 3 is 3, but then when I times it by 3, it's 9? Yeah, in computers, that's how it is. Because we do the remainder with the modulus operator. And that is 9 modulus 4 is 1. 10 modulus 3 is 1. So 10 modulus 3, we get that remainder of 1 here with our modulus. 10 divided by 4 is 2. Our modulus 4 is 2. Because 10 divided by 4 equals 2, because 4 times 2 is 8. But we have that remainder of 2, so we get the 2. And then 5 times 2 is 10, so we get 0. And those are all examples of binary operators, an operator that has 2 operands, not unary operators. Unary operators are something that we're going to talk about in a little bit, but none of the operators we have seen so far are unary operators. And a binary operator basically goes A, operator, B. It's something that has, this is what's known as the left-hand side, and this is what's known as the right-hand side. So a binary operator has a left-hand side that gets operated on by the right-hand side. But what if we get something like this? Is this going to be 1 plus 2, which is 3 times 3, which is equal to 9? Or do we want to do 2 times 3, which is going to be 6, plus 1, which is equal to 7? Well, obviously, this is going to be the winning option because just like in math, we have operator precedence. An operator precedence is pretty standard. It's going to be read left to right with parentheses being at the top. So if we did over here, say let's clean this up a little bit so we don't get too much going on. So if we came over here and put parentheses around this, then it would be 3 times 3 equals 9. But since there aren't, it's the other way, where we take our multiplication, division, and modulus as our next precedence. And then after that, we get plus and minus. One won't stay. So then we have to think about this a little bit, and this is what's known as mixed expressions. So in this very first case, we have an integer operator in integer, and that's very obviously going to give us an integer out. In the second case, we have a floating point operator, a floating point, which will very obviously give us a floating point out. But what happens when we have an integer operator, a floating point, or a floating point operator, an integer? What are we going to get out? Well, simply we're just going to get floating points out in both cases. So, pretty much if you have something like this, where you have 1 plus 0, so left-hand side, operator, right-hand side, this 1 gets turned into a double, and then this double gets used, which gives us a double of 2.0. Or I'll call them doubles a lot, but note they're just floating point numbers because for the most part, you'll use doubles in your programs.